Words about me. I almost finished my philosophy master's degree, but I started working in Allegro and decided that machine learning is more interesting. And this work conducted together with Dariusz Kajtoch. He don't like the presentation, so I'm presenting today, but we did a lot of work together. So let's start. Short plan, like short introduction and definitions, because I want everyone to be on the same page. And this is just basic definition for you to understand what I will talk later. I will show some results, some experiments, and conduct short analysis. It's like 3 small analyses of different topics, what I think is important. And in the end, we have limitations, future work, and problems. I think this is one of the most important sections because we don't have a lot of work about in-context learning and Polish language. And I think it's important to start with something and after that develop step by step. This won't be a long presentation. I decided it's better to show the most important results. And this seminar is based on paper that we are going to release maybe in months or 2 with Darek. And paper covers much more topics. And I will briefly maybe mention some topics that covered in paper but not covered in this presentation. And first of all, and one of the most important things, this is terminology confusion. Because if we talk about few-shot learning or end-shot learning, earlier days or maybe less popular definitions that we have annotated examples and we train our model, and we need to have really good method because we want to avoid, for example, catastrophic forgetting or something like that. We have set fit or tfew. This is one of the latest methods. And set fit is covered in paper, but okay. Can you see anything?
Something.
Okay, that's not good. But the first step, as I said, we train a model on n annotated examples, and step 2, we use this trained model to perform predictions. Straightforward, but nowadays, or maybe more popular definition nowadays, it's like few-shot learning. It's in-context learning with annotated examples. It means that we have the same annotated examples. We have examples that we want to make prediction, and we just combine them into one input, like simplify and combine into one string, go to model, and we have prediction. And examples of this is like decoder-like model GPT-3, Llama 2, and other. Nowadays it's really popular. So we focus only on this method in this lecture, and actually in paper, because we come to conclusion that it's much more important to test in-context learning compared to classical, let's say, few-shot, because we conducted a lot of experiments and it showed that maybe don't have a lot of potential and it won't be such useful compared to in-context learning node, if we talk about nowadays. So why focus on in-context learning? It's not research points. It's more about understanding our primal motivation. First of all, this is paradigm change because use LLM on small amount of data, and this is a real life scenario. And in Allegro, we see a lot of use cases where people can use this. It's much easier to try and teach someone how to train models, for example, or fine-tune models, and useful for fast prototyping. If you have hackathon and you want to create something, some product or something that looks like a product, you can use this prototyping. And in context learning, very useful. And the last one, this is accessible tool for non-technical users. It's very important, not in academia, obviously, but in industry, when we have a lot of people coming to you and asking, how can I don't know, create some type of classifier or perform some small task using machine learning. So in-context learning can help in all of these cases. Our, I would say, research motivation, first of all, is like see how language model work with the Polish language, because there are multiple papers about multilingual evaluation, and usually there is no Polish language, I would say. Or if we talk about multilingual evaluation, there is a problem because we have translated data sets, and it's difficult to decouple performance from something that originally in English and something that you use from your, like, in our case, Polish language. But we will talk about that later. Yes, let's check with the hypothesis. But let's go with definition. And very, very briefly, informal, what is in-context learning? In GPT-3 paper, you have some kind of confusion, in my opinion, but in context learning, this is something which occurs within the forward pass, and in other places, they called in context learning as future learning, as I said, this is some kind of confusion, but we have model given few demonstrations of the task at the occurrence time as conditioning, but no weight updates are allowed. So let's just see how it's constructed. And using this example, we provide some basic definition. First of all, we have task. Actually, this is called tick. Did you know? I think we want to predict whether following question answer pair is connected. We have two sentences. Okay, answer is like sentence 1 and sentence 2, and we need to predict whether it's connected semantically. And okay, difficult to say actually, yes.
A bit. But
yeah, you have to.
Yes, tell us.
And here we see. Okay, we don't see.
We should see.
This is it's called template. This is form which our input should be wrapped. Okay. Yes, and it's called like question answer label. This is form of input that we need to use. After that, we have instruction, because if we talk about in-context learning, in input we should describe our task and how model should perform or should solve this task. So if we combine this, we have something like that. We have optional system prompt. It's used in different chatbot models when you describe how chat model should perform. I think the most common is like your useful and kind chatbot model and blah blah blah. But this can be used for solving tasks, because I think you can see, but here we have system prompt. It's like rozwiązujesz zadanie klasyfikacyjne w klasyfikacji dla języka polskiego. So we define what should this model like being driven by. Okay, and now this is zero shot. We have examples that we want to predict. We have description.
Przepraszam, spróbuję zobaczyć, czy widzicie gdzieś kontrast ekranu, kontrast obrazu? Może wtedy? To działało.
Ja mam bardzo dobrą metodę.
Tak. Myślę, że to jest.
Dobra.
Do czasu wymiany projektora nie robimy seminariów chyba tutaj. No. Okej.
Ale
I coś zrobiłeś, czy nie? Bo...
Nie, no.
Okej.
Już się wstydzę, zostałem skarcony, jak chcesz to
Okay. Actually, in the next slide, we won't have so much colors. It will be only black, but I'm not sure about that. Okay, and this is called zero shot. We don't have examples with input and labels, so it's like zero shot. Oh, color, yes. And we need to just predict what's going on after that. If we use the color-like models, this is like predicting next token. Obvious. If we go into few shot regime, we have other example. It's called demonstration, and we have label because it is annotated. And it's very important moment actually, because we need to have something like called verbalizer when we map our label, because in data set we have 0 or 1. 1, it means that the sentences are connected. 0 means it's not connected. So we need to map into words that can be used for model to show or to predict the label. So we have them like that. Can you see my mouse? Yes, in the presentation?
Yeah.
Okay. Here we have system prompt, here we have instruction, here we have our demonstration. It's only one, it's like called one shot. And we have example, we want our prediction. So this is example from the code. We have instruction. Ocenczmy następujące zapisy z uczciwy lub nieuczciwy. We have a demonstration, but it's called like template. And we have label mapping. It's important for the model to choose appropriate mapping. And we go into evaluation methodology, why we focus actually on classification tasks. First of all, because we have a lot of, maybe not a lot, but multiple data sets in Polish language for classification. So we can create some versatile benchmark as easy to evaluate. Comparing to generative tasks, you just need to use F1 score or accuracy. Comparability, results can be compared with popular models. And you will see that we use the same metrics as used in Play or literature benchmark. And the last one, important in industry, this is popular real-life task. But we will talk about it more in the section about future work. Okay, this is table with all data sets. Few comments about that. We have multiple data sets with 2 classes, 3, 4, 6. It's like NKFNF and 12. We decided to test as wide number of classes as possible. Usually we will have 16 demonstrations, for example, so we choose 12 to be maximum number of classes. In reality, you can have much more classes, and it only means that it's not, maybe this task is not suitable for in-context learning. After that, we use metrics, the same as in Play and literature. And I think this is very useful because we have different lengths of one example. And I'm not sure if you can see, but you have, for example, for PolMO 2, you have 758 average length, and compared to NKFNR or CBD, it's like less than 100. So this is influencing how many examples we can have in demonstration, or whether model can solve tasks if, for example, one example is really, really long. And we will see in it how we're sampling such a demonstration. We use training dataset to sample n demonstrations. And for example, for 5 shot and 3 classes, we sample something like that we sample all available classes and start from the beginning. I'm mentioning here why we're doing that. First of all, we want to have representative demonstration set. We want to be sure if we use, for example, I don't know, 5-shot, that model at least one example of every class can see. Another reason why I'm mentioning this, how we sampling, because usually class label here really influencing model prediction. If model collapse into a constant predictor, it will constantly predict one label, and usually this is label from the last demonstration. Okay, and we have test because all our results reported on test set. We have test example K. We have template store. We have many templates for every task and label mapping. And this is templates we just put down from our head actually. Dariusz have a really good idea that we can use templates from books used for teach student foreign languages, because we need to have we evaluate Polish language model actually, or not Polish but English language. If we talk about, I don't know, GPT-4 or ChatGPT, we need to use something that will be more or less useful for this model. So having template from books seems to be a good idea actually. So we combine into one input and it goes into model. And here we have two options how we can parse our output or maybe get output from the model. First one, this is grid match, and I will cover only grid match on seminar. And another one is log prob. It's like use log probability of every label. So you just use you just calculate log probability for every label given such conditioning as our input. I'm not talking about the probability on this seminar, but in paper you can find results for some models. But about grid match, it's important to understand how we evaluate because it influences metrics. For example, we have two labels, 0, 1, and it's matched to positive and negative 10. It's just input, model, max steps. It's like generate, for example, for 10 steps every time. And we have generated string. And for example, it's not real generated string, but I observed something similar from real data sets and real generated strings that we have something like positively, negatively, and some rubbish in the middle. And first of all, what we are doing, we use grid match. We ignore the whole string, and we use the first overlap with the label. For example, if we have positively in the beginning, we think, okay, this generated string means positive prediction. Why we're doing that? Because, as I said earlier, we have max steps generation. So after some step, model forced to continue generate some text, and in different models, in different cases, models behave differently. And in some examples, some models can generate another label. Some model can generate just copy demonstration into generated string. And one important thing, if model generated nothing useful, we mark this as invalid prediction. We do not assign some of the label, and you will see that really impacting prediction, because in some metrics and some experiments you will see zeros. It means model just can't follow instruction and do not generate some of the labels. Okay, going into results. First of all, baselines, and This is very strong baselines. I would say, first of all, random guessing. And when we have all available classes and sampling every time, most frequent, we use training dataset to choose the most frequent label and use it as constant prediction, constant. And the Herbert large, this is fine-tuned model on the whole training dataset. So for us, it's like biggest order or maybe limit that we're going, like we want to evaluate our model. We assume that if model can solve in context learning task something like this, it means really success. But you will see that it's not possible now. In parentheses, you see results from benchmarks. It's like copy pasted. All other results is our result. We just retrain this model on every data set. Okay, yes, one lower bound. Yes, we're assuming that we are evaluating lower bound of in-context learning performance for the Polish language. We evaluate on all templates, but we do not perform a heavy prompt engineering and something like that. So let's start with the most promising models. It's like GPT 3.5 Turbo. We have two modes, like 0-shot and 16-shot. Actually, all this decision based why we choose 0 or 16 examples or why we perform such experiment or another is based on cost, because model inference can be really costly. So here we have results. I don't want to talk maybe about every metric on every data set. If you have question, you can just ask. If you have question, if you're interested in some of the metric, I just point out few results. For example, if we have incorrect and sensitivity news, these data sets have 6 and 12 classes respectively. And you can see that there is huge gap between fine-tuned Herbert and GPT-3 in-context learning mode. Okay, this is very challenging data set, so this results is really low, but it's better than most frequent. And we think that this is success, actually. Okay. Yes. And we have only one case where adding demonstration actually hurts. And from 74, it comes to 72. But I'm not sure whether it does have any meaning, because as you can see, most frequent class has 74.4. Say this is F1 binary score. So it means this is worse than constant, not frequent predictor. If we go into pound 2, we have similar results, and we have similar observations that adding a demonstration can help, maybe compared to CBD. CBD, this is cyberbullying detection. And one of the reasons why this score dropped so much, we're assuming that found model, we use Google endpoint, and this is just safety checks, because if you use endpoint, you don't have access to raw model. Let's say you have access to some system. So this can be described as, okay, we added demonstrations, and this is demonstration show cyberbullying, and because of that, model blocked or generated something like, this is not appropriate input, or I can generate input based on this abusive something input. Okay, I think this is important. Yes. And GPT-4, it's really cost a lot, so we use only experiments for zero shot, and it shows the best result. You will see comparison between everything. And one of the most interesting result for us, this is the result, because GPT-4 shows better performance than Herbert Clark fine-tuned. So it means, first of all, probably GPT-4 were trained on Polish Wikipedia, something like that. And the second one, GPT-4, in order to solve this task successfully, you need to have knowledge. And it's like world knowledge, not knowledge that you can get, for example, from training data set like Herbert. So GPT-4 showing really good performance here, but if you compare other tasks, it's not as good as can be, for example, on CSTV use, because we have a lot of classes. This performance is really low compared to Herbert, and even compare the most frequent baseline. So from this moment, we can state that if you have a lot of classes, for example, 12, maybe in context learning, it's not ideal solution for you. But we go into open source model, and I will really quickly discuss Llama model, Llama chat, and some model that were fine-tuned on Polish language. First of all, short introduction. We have Llama 2 model. It's trained on 2 trillion of tokens, and in the paper they stated that Polish language, it was like 0.09% in training data set, and it has context length 4,000. It's important because, as I said, if we want to have 16 demonstrations for English language model, basically, we need to have a tokenizer that can tokenize this input in something that can fit into this 4,000. And Llama chat is just fine-tuned version of Llama 2 with like supervised fine-tuning and different reinforcement human feedback methods. Okay. Here, I mean, you can just ask if you're interested in some specific result. I will only point that we have zeros here for 16 chat, mainly here for chat model and the normal model. Here we have result first for normal model, the last for this is chat model for different sizes. So it means model just can follow instruction and generate proper label. It's just starting to copy example or generating some nonsense. We see that actually there is no, I would say, correlation. Okay, we have some correlation that this matrix higher than this, but actually there is no connection with model size or whether it's chat model or not. Is showing really weak results. We saw that chat model can be more useful because in chat model you have system prompt and this model is more trained to follow instructions. But in reality, no, and you can have much worse results using chat model comparing to normal Llama model. As I said, the biggest model, and actually it's like seems to be just worse than random because we see that every time model start generates some wrong output, not label, not following labels. But if you compare 0 shot and 16 shots, you will see that obviously 16 demonstrations is too much for Llama. And we will look at tokenizer and how to tokenize examples and understand why this problem appears. So in GPT-4 and GPT 3.5, you have longer context input or context window, and this is one of the most important feature of the model if you're considering to use this for Polish language. Okay, we have something like called true2. It's fine-tuned on 1.7 billion tokens. Actually, there is no a lot of information. I just copy paste from Hugging Face. This is some conversation in Polish and English. So we're assuming that this model should at least follow Polish language input and generate labels. We will see that. One second. Okay. We will see that actually this shows better performance, but at the same time, 16 demonstration is too much and can cause some problems because Polymo is quite a long data set. And we will return comparing Llama and True in a minute. And the last model of the similar size is Mistral. And this is, there is actually no information about retraining data. And this is in paper, there are things that fine-tune on public instruction data sets from Hugging Face. I'm not sure that I completely understand what this means. And this context length 8000, as I said, it's important feature. So you will see in a minute. Okay, maybe. Oh no. See that this model, at least for every task, can generate something, can follow labels, something like that. But this model weren't trained specifically to be multilingual. It's trained to be English language model, but it's pretty good for its size. It's like 7 billion. Maybe some small off top. I know that for other languages, Mistral show good results, and after proper fine tuning, it can be useful because if we see true on this matrix, it's based on this matrix. You can say that it's not useful to solving some kind of tasks. Okay, we have a really big table here, and the color that you can see actually. This is yellow color, or maybe orange, and shows best performance among models with similar size. We have Llama from 7 to 13 billion parameters, Mistral and True. And as you can see, or you believe me, Mistral shows best performance almost on every task, and it's like smallest model. So it's just as a recommendation, use Mistral. At least start with Mistral and see what can give you. Okay, yes, and we're almost done with boring tables. Honorable mentions GPT-2. It's not working at all. Actually, this is generating. Okay, maybe no. This is generating absolutely rubbish. As I observed, this model actually, the biggest one, can follow basic instruction and generate proper label, but in many cases it generated just the last word of the input. It's just copying this word into generation. One interesting point that probably it's connected with tokenizer. If you try to generate text with GPT-2 and it's generating some nonsense, try to add space in the end, and this magically can help. Okay, it's not helping here, but it can help to generate anything that has sense or at least label. Krakow, this is fine-tuned Llama 2 model. I'm not putting into result because I can't find real information on Hugging Face about this model because the page is deleted. So we need to perform some kind of investigation, what's going on and what happened. So that's all. I don't know if you have any questions. it's difficult to follow, but in my opinion, there is no need to follow to understand that actually it's not working good. Maybe GPT-4 at least follow instructions, but maybe some small or fast analysis. Okay. Okay. First of all, as I said, we put a lot of emphasis on tokenization because, as you can see, we have here two datasets, encode and path. This is the shortest on average, like number of token input token dataset, and this is the long one, the longest. And we have GPT-2, GPT-4, Llama, and Mistral. As you see, but here we have distributions of number of tokens, how these examples tokenized. And you can see here, this is GPT-2, it's mean near, I would say, 25 tokens, for example. And another like detail right from the right hand, you have GPT-4 and Mistral, and this shows this is really problematic for open source and commercial model to tokenize Polish language. Okay, sorry for so much text, but we can compare. Like we have a sentence, and we try to tokenize this with GPT-2. It has only 14 tokens. GPT-4 has 26. Llama and Mistral have near 30. And you can see, for example, some words is almost letter by letter tokenized. So this not only problem for input, actually, this is problem, three problems. First of all, it's cost. If we talk about GPT-4, it's really pain because you need to pay much more comparing to English language. Input length, as I said, you need to pay attention to to context window, because if you have 4,000 token English language model, it's not enough. And output parsing, if this connection is weak, you will have, for example, I don't know, max steps, 10 steps of generation, and this won't be enough to generate every label that you want. Because, for example, we can have label tak, nie, yes or no, or we can have more longer labels that won't fit into output generation. And for example, we have, as I checked, we have many examples where output is not just started generated with some dots. After that, model started generating label, but not finishing generating label because this label consists of 5 or 4 tokens. Another one, okay, it's impossible to see, but I will try to describe. This is about templates, because for every task we had more or less 10 templates, or maybe 8. And here you can see or can see that if we sort this template based on GPT-4 performance, this is yellow line here. I hope it's yellow. I can remember actually, I would say in the paper or in presentation. You can see that in some datasets, other models actually follow a behavior of GPT-4. It means if we have templates that guarantee high scores for, I don't know, this dataset, I can remember its name, and it means that for other model, the same template will guarantee, not guarantee, but will probably have higher score. Maybe it's not working perfect, as you can see here. You have just only one template that can give similar performance as GPT-4 model with the same template. But maybe the most important outcome of this label template really brings a lot of variance, and if you want to have decent performance, you should actually start with template and experiment a lot, not focusing on demonstration examples or something like that, but just start with templates. Oh, this is another picture. Okay. But this shows differences in performance between few-shot setting when we have 16 demonstrations and zero-shot setting. And not going into details, the most important that you have really high variance on every task, except the last one, it's like CSTD news. As we saw earlier, our models just don't know how to solve this task. So these templates don't have high variances. It's like near zero, and that's all. But for other tasks, I suspect this is Polish music poses, and you can really have small or big or really big gains, like from 0 to 80 F1 score. And the last one, it's not actually analysis, it's where our hypothesis, because as you observe, we have a weak tokenizer, and for Polish it's not suitable, but okay, it's suitable for English. But what happens if we translate Polish dataset into English and use the same models? First observation that, okay, we have a good tokenizer and English language. Second observation, actually, I forgot to put paper into references, but there was a paper showed that if you have shorter input, it's more probable that you will, you will have your model will use all available tokens. It's called, this paper called something in the middle. I think Dariusz remember name. Maybe update slides with the name of this paper. But main idea, if we have English language input, we will have lower costs, we will have better performance with this hypothesis, and we will use more effectively demonstrations. So this is the result of tokenization, and we have inverted actually distributions, because now here you have actually this is part from standard scenario. You have Polish language input, you have GPT-2 tokenization, the most effective tokenization, but here you have GPT-2, it's like the same distribution as GPT-4 for Polish language. So when we translate it back into English, we can observe that, okay, we fixed the tokenization problem, but what about performance? And sorry for this big picture, we have only results for parts. And you can see this is 4 categories. We have first one in every category. This is zero-shot Polish language. After that, zero-shot English language, and zero-shot, two-shot, or English language, two-shot, and Polish language, 16 shots. And we have GPT 3.5, 2, true, and other true bigger, like 13 billion parameters. Or we use GPT because it show promising results. We use Palm because it's like big model, and on English tasks it shows similar performance than GPT-4. We don't use GPT-4 because it costs a lot. We try to use True because we were interested in what's going on with model after it's fine-tuned Polish language. So you can see, first of all, it's not working. Translating into English, drop in performance and consistent drops. Maybe in GPT-3 it's similar performance on path. For some reason, too short translated dataset shows 0 performance. Model just this such big model usually follow instruction and generate proper, not proper label that we are assuming that this model should generate, but no, something happened and this result is just not working. And the same situation for other models. When you have English, you have word performance. And if you add in English, to translate the data set, some demonstrations, you have a consistently worse result. Actually, for this biggest model, it's working the same, because as we saw earlier, if you add demonstrations to one, for example, it's really noisy and it can work. But if you are in either GPT-4 or PALM or GPT 3.5, it's actually useful and you should consider this. So,
what kind of translation models did you use?
oh,
Because the result might be influenced by the
Yes,
translation model.
yes.
If it's rubbish, then it's not surprising that translating to English doesn't improve.
actually, we asked Allegro translation agent team on the best model to translate, and they said that they gave us model. Maybe Dariusz can.
Okay, so it was like the internal Allegro model.
Yes, yes,
Okay.
yes. And it's on
Yeah, it
par
was
with
pretty good,
translate.
yeah.
It's up by some random.
Yeah, it was pretty good.
And yes, I'm not talking about the translation model is like limitation factor. We're just assuming that, okay, we can live with this cost, but we just want to see what happens. And limitation section, first of all, quality of data set. As you saw, based on baselines, we have a lot of data set with unbalanced classes, and using that, if model turns into random or constant predictor and using label from the last demonstration, it can have high results, but actually this model is not capable to perform in context learning. Yeah, I observed something like this in GPT-2 model, the biggest one, when for some template and some demonstration, you can have really good result on par with GPT-4, but it's actually nonsense. And this is CST we can use dataset is really unclear. For example, me and Darren don't know how to solve it. So it's very noisy. So, CBD have really no noisy input. So this is problems of quality. And one of the potential solutions, if it's company, actually, you can use your specific internal data sets. Other team in Allegro using such data set and testing models, our aim were to use open source data sets. So this limitation states more emphasis on output cleaning. As I described, we have really dummy system of cleaning output. And in many examples, it's crucial actually how you clean output of your model. And there are some potential recommendations. For example, you can use some regular expression stuff or use output parsers. You can force model to generate some kind of output, or you can use low probability. And in this case, you don't need to just control generation. You just have scores for every label. Okay, I think this is maybe not like concrete limitation, but I think it exists. Current benchmark is built from standard data sets. As I showed, we just sampled from training data set examples and all. Creation of specific benchmark for future is needed to measure progress in appropriate scenarios for in-context learning. As I repeated many times, in-context learning, in our opinion, is useful for some specific scenarios. And in Allegro, we use in some actual specific scenarios. And here on open source dataset, we just take dataset and trying to solve using in-context learning. We don't think that, okay, maybe we should consider tasks with short inputs, and it will be much more appropriate for context learning, something like that. Because if you are using, for example, Polish abusive clauses dataset, and it's have really, really long input, you can say a lot about in context learning, but you have limitations as tokenization, context window, and it's more about such limitations, not about in context learning itself. And there are two good papers how you can create better benchmark and better few shot actually benchmark.
Can I have a comment on that?
Yes.
From experience, I also noticed that it's not always useful to give demonstration, but to give definitions. So if you have like two classes, whether this is abusive clause or not, it's sometimes better to tell the model in a prompt what does it mean that the clause is abusive. So it contains these examples, this something, something, something. So to give definition and not demonstration. So example of the abusive clause and label abusive. And in this sense, this construction of like examples for few shot is completely different than, as you said, sampling some examples from the standard data set, because it's just easier to write a good definition or write a really specific example, a very specific demonstration, like to prove that point, to give extremely difficult like corner cases, because on the average the model will know how to solve this task, but you need to give them in a prompt some really difficult corner cases. And if we sample randomly from the training set, it may be not useful because those examples are too easy and or doesn't say anything like useful.
Actually, it's really useful remark, because we notice similar if, for example, we have zero shot as you saw, and we constructed instruction as like you have some classes, and based on how you define these classes, how you describe this classes, it's really changed a lot, and your performance can really vary based on that. This is okay. This last one. We just evaluated lower bound of the potential performance because we use automatic output parsing for every tasks, and we don't use some prompt engineering or some fancy methods because it's just first attempt to make something in context learning for Polish language. So I think it will be possible to have much better result with appropriate work from engineering. So outcomes, we show lower bound for context learning performance, and we show that large commercial models showing promising results in fusion regime, but lag behind full fine-tuning. Not surprise. It's difficult to evaluate and compare performance on near random level, as I said earlier. If you look at results on GPT-2, you can compare results, but this is more than random. And in my opinion, there is no sense to compare something like noise. And in many models, you will observe something like this. For example, for Llama, if you have bad template, you will have just random noise. And there is no difference between big 17 billion model and small Mistral 7 billion model. It's the same, right? Okay. And while optimizing in context learning performance, experimentation with templates and demonstration is crucial due to high variance. And we can add here further remark about that you need to understand how to construct this instruction. More demonstration is helpful if context window is large enough, but not in every time, in every case, but you can just try it once or two and see whether it's helpful, and based on that, go next. But as Piotr said, I think I would agree if we talk about open source model, number of demonstration actually means nothing. And more research is needed, and we have more results in common paper. So I think that's all.